Hi, welcome back to our continuing discussion on average value. It's a very big topic for us. We talked in the last video about this f of c number. This f of c is what we call the average value. Remember that it's just the height of the rectangle. If I could squish this area of this parabola inside this rectangle, it would have a height of 16/6 right there. So another way we donate f of c is by using this terminology here, f sub a v e. So if we go back to our original integral right here, what that's kind of telling us here is if I look back here, remember I have this parabola right here from 0 to 2 at a height of 4 up here. What we're saying is I can draw a rectangle between 0 and 2 that has a height of 16/6, and this area will be exactly the same. There we go. That these areas, there you go. That those areas would be exactly the same. This 16/6, that is our average value. That this rectangle's area would have the exact same as our other functions area, as a functions area. So we can denote this by using, we use a little phrase called f sub a v e. This is going to become your fave. So we say f of c is our fave, because it's going to be our favorite function in here. Looking in terms of that rectangle, we look in terms of our rectangle. Well, if this is my average height, so my average height, if I look at my rectangle, the length times the width, and I could take that f of c, multiply that by the base. But remember, the base is just really b and a here, so it's b minus a. So of course it says b minus a, and that's going to equal the area of our function under our curve, f of x dx. That this is the area of our rectangle, and that's going to equal the area under the function. Now, solving for f of c, remember f of c is our fave, we can divide. And if we were to do that, we would get from a to b f of x dx divided by b minus a. And that should look a little familiar to you, right? When we solved it over here, when we found our average velocity of the bicycle, we did something similar to that. We normally don't like to write it this way. It's kind of messy. It doesn't bother anybody, but sometimes people, the fraction scares them. So we can go 1 over b minus a times the area from a to b f of x dx. And this formula right here is what we call our average value. So let's take a look at an example. So we're given this parabola right here on the domain 2 to 5. We want to find the average value of the function, our fave, and then they want to find out where the average value equals the function. This is the one that most people miss. It's very similar to what we did for MVT and IVT. And then we want to sketch the rectangle whose area is the same as that graph. And that's going to be pretty easy to do. So first, let's just look at this function. We're going from 2 to 5. Now, I know from experience I have my vertex on the x-axis at 3. And let's see here. If I plug in 2, I'm going to have a value of 1. And if I plug in 5, I'm going to have a value of 4. So there's our happy parabola right there. So we have our area. And what we want to do is to find the area under this function. We won't find the average value. What do we say? You find the area of the function and then you divide by its base. The area of the function divided by its base. So for part A, if I want to find my average value, my rule is find the area under the curve from 2 to 5, f of x dx, don't forget the dx. In this case, we can rewrite this as x minus 3 squared dx. And we're going to divide it by the length of the base. This would be 1 over 5 minus 2, which is 1/3. So let's go ahead and evaluate this. Now I'm going to use substitution to evaluate this. So I'm going to let u equal x minus 3 du is, oh, that's nice, just dx. That's telling me dx is just du. That's what I want. Now, because I'm using u substitution, I will change my domain. When x is 2, u is, what's 2 minus 3? Negative 1. When x is 5, u is 2. And if I rewrite this, we would get 1/3. Be careful, I changed my domain. Negative 1 to 2. This becomes u squared du. And when I evaluate this, we will get 1/3 times, this becomes u cubed over 3 from negative 1 to 2. So we will get 1/3 times, be careful, don't just, you can factor out the 1/3 if you want to. It's not too bad to do though. This becomes 8/3. Be careful, we're subtracting minus a negative 1/3, so it becomes a plus 1/3. And this becomes 1/3 times 3, and we get 1. Now what does this one tell us? This is the average value of our function. That's our average value, or it's the average height of our parabola. So if you look at the parabola right here, it goes from 1 to 0 all the way to 4, but what this is saying is that the average height of all of these y values is 1. And now remember how we get that, right? This was the base, we divided by the base, and there was the area of our function. So that's part A. All right. Now part B says where does this occur? And this is just like MVT right here. This is just like our mean value theorem. So we want to find out where f of c equals our average value. It's a formula. So where's my average value? 1. What's my f of c is my function, excuse me. Sorry, that's just going to be our x minus 3 squared equal to our average value, which we said was 1. And I can solve it. I get x minus 3 equals 1, or x minus 3 equal to negative 1. Be careful, when you square it, you get two answers. So I get x equals 4 and x equals 2. Both of these are within our domain. You can include the 2. You can have an average value at any point this time. And then the last part is part C. Part C says draw a rectangle whose area is the same. So if I were to draw a rectangle from 2 to 5, it would have a height of 1. So this rectangle right here would have the same area as this graph right here. And it's easy to verify. It's easy to verify that. What would be the area of this rectangle? 3 by 1, which is 3, which is what we said here. The area is 3. The area of our rectangle there is 3. Very easy to do. But the question is, okay, well, what does this 4 and 2 mean? Well, if I were to draw over here, if I were to sketch around, at x equals 2, the height is 1, and at x equals 4, the height is 1. That's what 2 and 4 mean. All right. Go on to video 3, and we'll take a look at just 2 more examples. Okay, the last 2 won't take too long. I'll see you then. Bye-bye.